In last class, we introduced actually very important materials, right? So it's about the other trigonometric functions. Code is a tangent, secant, cosecant, and cotangent, right? So we can use the reference angle to find these values. Now the technique is use the reference angle to find the sine and cosine first, right? And then use their relationships, right? Formulas to find tangent, cotangent, secant, cosecant, right? So we have all those. Now, today we're going to move on to introduce some more interesting relationships among the trigonometric functions. All right, so here is alternative forms of Pythagorean identity. Okay, so anybody remember what is a original form of Pythagorean identity? Do you remember that? It is what?
Sine
Cosine.
squared.
Let's say cosine. All right, let's say cosine squared t plus what? One?
Sine.
Plus sine. Okay. Plus sine of sine squared t equals 1. Okay. Now this is the original one. Okay, let's put it as a star. Okay, because it's the original one. All right. Now, first, let's divide both sides, all right, by cosine squared t. If we divide cosine t on both sides, 1 over cosine squared t, cosine squared t plus sine squared t equals what? 1 over cosine squared t times 1. Is that right? I basically just divide cosine squared t on both sides. Yes? All right, so then some magic happens. All right, so you see that cosine squared t and cosine squared t cancel out, right? So we got first term is simply 1 if you use the distribution rule, right? So this one goes here and multiply this one, right? So for the second term is what? Sine squared t over cosine squared t, all right? Equals what? 1 over cosine squared t. Does that make sense? All right, but this one can be seen as, wow, something interesting here. All right, it is, since the top and bottom are both squared, so I can just write as sine cosine t in the parentheses square, right? And this one is its own square, so it's equals 1 over cosine square. 1 over cosine t squared. Yes. This is true, right? So, and then I found something interesting here. So what's in the parentheses here? Sine over cosine, right? So what is that?
Tangent.
Tangent. Yeah, that's the tangent. Tangent t square, right? So square t, right? And equals, what is in the parentheses in the right-hand side? 1 over cosine t. Secant. But you take the square, right? Secant square t. Well, you see, we got another equation here. 1 plus cosine square t plus equals secant square t. Yes? Okay, so we got something interesting here, right? So 1 plus tangent t squared, tangent square t equals secant square t. Now, similarly, if we divide both sides by sine squared t instead, all right? So we will get the second equation, all right? So let me just Okay, I think I have certain space here. So if I divide both sides by 1 over, oh gosh, I hate it. Oh gosh, sorry, accidentally got to another place. Okay, all right, here we go. All right, so if I divide both sides by 1 over sine square t, all right, this is a cosine square t plus a sine square t equals 1 over sine square t times 1. Yes. Now this again implies, all right, so by distribution law, right? So multiply this, multiply this. The first one is cosine square t over sine square t plus 1, right? So 1 over times sine, all right? So that's canceled out, plus 1 equals 1 over sine square t. This again equals what? Cosine t over sine t squared plus 1 equals 1 over sine t squared. Yes, so we have this. Now we also see, right? So similarly, this implies that cotangent, right? So cotangent square t plus 1 equals what? Cosecant square t. Yes? All right, very good. Okay, so we have this another equivalent identity. All right, so there are two of them, right? So one is 1 plus tangent square equals secant square. 1 plus cotangent square equals cosecant square. Yes? Okay, so we have these alternative forms of Pythagorean identity. Okay, well, you see these ones, right? So you see these ones. Okay, so these are the two. All right, so we got to know how to use them and memorize them. All right, so this is very important. Now, let's consider this example. All right, Natalie, can you read for us, please?
Yes. If cosecant t equals negative 13 over 5 and t is in quadrant 4, find the values of the other 5 trigonometric functions.
Okay, very, very good. All right, very good. So, okay, well, for this one, cosecant t is negative 13 over 5. All right, so I believe we can use something interesting to, many methods actually, to find this one. All right, there are many methods to solve this problem. All right, so one of them is to realize that, okay, so we have what? Cosecant. Cosecant equals what? The cosecant is already there, right? So cosecant, what is cosecant t? I can write 1 over sine, right? So it's 1 over sine of t, right? So this one equals negative 13 over 5. So this implies that what? What is the sine t? Sine t is going to be the reciprocal of this, right? So it is negative 5 over 13. Yeah, sine t is already found, right? So I believe everything else will be simple, right? Sine t is negative and t is in quadrant 4, right? Quadrant 4. So we can use what? Pythagorean theorem to find out the other cosine t, right? Cosine t will be positive, yes? Okay, but that's going to be one thing, right? So you can use use Pythagorean identity to find cosine t, right? Now, after you find sine and cosine, then everything else will be good. Does that make sense? Yeah, I think everything else will be, it's like this is given and find others, right? So we did this one before, right? So this is one way to solve this question using Pythagorean identity, using the original Pythagorean identity, right? But for this question, we can also do this for another using the alternative forms, right? Instead of the original Pythagorean identity. Okay, so since we just learned these alternative forms, let's use instead the alternative forms. How about that? Okay, all right. So since the cosecant is given, right? Cosecant is given. So we are going to use, as we can see, the cosecant is given. So we can use the second alternative form, right? Second alternative form. So, sorry. Okay. Okay. Based on based on the alternative forms of Pythagorean theorem identity. Right, we have okay, well, one way. All right, let me say we also have, okay, so cotangent equals this one, but some equivalent forms is going to be what? Now tangent square t equals secant square t minus 1, right? So this implies what? Cotangent square t equals cosecant square t minus 1, right? So they are all equivalent, correct? So let's firstly put this one here, all right? All right, so we have, all right, cotangent square t equals cosecant square t minus 1. So which equals what? Which equals, which equals what? Negative 13/5 square minus 1, right? So this implies, so negative square doesn't matter, right? So it becomes 169/25 minus 1. 1 is what? 25/25, right? So 25 of 144, yes? Okay, so it equals 144/25. Okay, so, all right. So that is to say we have square equals this one, right? Now, since what? Since t is in the fourth quadrant, in quadrant in quadrant 4, in quadrant 4, okay? In quadrant 4, now cotangent t equals cosine t over sine t. Now this is positive or negative? How do you think?
The negative.
Why?
Because your cosine would be positive, your sine would be negative.
Exactly, right? Because cosine is positive, right? and sine is negative, so cotangent will be negative, right? So it's less than 0, right? Hence cotangent t equals what? Negative square root of 144 over 25, and this is negative 12 over 5. Does that make sense? All right, so we have this one. All right, we have, since t is in quadrant 4, cotangent t is less than 0, and therefore cotangent t is negative square root of that. Okay, now, since then we were going to try to find out cotangent. Then this is a cotangent, right? So we know that cotangent equals this one. Yes, cotangent equals this one. And also, if we multiply sine on top and bottom on both sides of this equation, we have cosine t equals what? Equals sine t times what? Cotangent t. All right, equals what? Cosine t over sine t, right? Cosine t equals this one. If this one cancels out, they are the same, right? So, but this one equals what? Sine t times cotangent t. Yeah, sine t, and this is cosine t, cotangent t. Yes? Okay. Then we already found the sine of t is given here, right? So negative 5 over 13 times cotangent is negative 12 over 5. Yes? Now what is that? I believe negative negative cancel out, 5 and 5 cancel out. This is simply reduced to 12 over 13. Yes? All right. So I believe from now, we can find everything else, right? Sine is known, cosine is known, right? And also cotangent is also given. And then I think the only thing we do not know is going to be, let me just add here. I'm going to add it on the top. All right, add on the top. So tangent. So we already found what? Cotangent, right? Cotangent is given. Sine is known. Cosine is known. We already had 3, right? 3 and 4. So cosecant is also known, right? Cosecant is a given. So what's left?
Tangent.
Tangent? Okay, tangent. Tangent t is what? 1 over cotangent t, right? So it's a reciprocal of cotangent. So that's what? Negative 5 over 12. Right? Okay, now what's the remaining one?
Second.
Second, right? Second t. Second t equals what? 1 over cosine or sine?
Cosine.
1 over cosine t. All right, very good. All right, so 1 over cosine is, let me see, it's 13 over 12, right? So which is the reciprocal of cosine. So we know that that's going to be 13 over 12. Okay, so I believe we already got everything. Now it's everything about the other 5, right? So 1, 2, 3, 4, 5. We got all the other 5 trigonometric functions. Yes? Okay. All right, so that's good. We got this one. All right. You see, this is something about the relation. All right, so let me just say something about the trigonometric functions. They are, you see that there are 6 such functions. Their relationship is, they'll have very, very close relationships. right? The definition there, the most basic one is the Pythagorean identity. Sine squared plus cosine squared equals 1. Okay, and then the other ones will be their different definitions based on the right triangle, right? Based on the right triangle. So cosecant is 1 over sine, right? Secant is 1 over cosine, right? Tangent is sine over cosine, cotangent is sine. Okay, some reciprocal relations, right? Reciprocal identities. And from these ones, we can get like really interesting other forms of relations. Okay, so like these ones, right? Like these ones. Now we need to be able to, hope in the future, all right, when we've got more used to all these, got better understanding of these functions, we can use different forms or different relationships, and you can select the most convenient one, right, to solve certain problems. Okay. Now this is the other forms of Pythagorean theorem. All right, so 1 plus tangent equals secant square, right? Or tangent square equals secant square. Cotangent 1 plus cotangent square equals cosecant square. Okay. Now, okay, let's say this. Could you please go ahead and solve this question? All right. Can you please go ahead and solve this question? Okay. All right. So let's consider this one together. All right. So this one is a little bit tricky. All right. You have to determine the quadrant based on the given information. All right. So here t is just give as greater than 0, less than pi, but it's not enough. Right. We need to determine the quadrant at which it is located. Yes. Now this is actually implied from the value of secant. All right. Since the secant is 17/8. All right. So we know that cosine t equals 1/secant t, right? It's 1/secant t and equals this one is greater than 0. Now cosine is greater than 0. It must be in quadrant 1 or 4. Yes, quadrant 1 or 4, because cosine is x coordinate, right? So cosine t is greater than 0, so it must be quadrant 1 or 4. Now also, since t is greater than 0, less than pi, with cosine being greater than 0, you can see that it cannot be in the second quadrant. Yes, if it is in the second quadrant, it's going to be cosine will be negative. Yes, so it must be in the first quadrant. This is a very key step, all right, to identify that it is in quadrant 1. Otherwise, you cannot find the value for tangent, right? Because it is in quadrant 1, right? So based on the alternative forms, all right, tangent equals secant minus 1, 6 squared minus 1, plug in, equals this, right? Equals this one. So since t is in quadrant 1, tangent is positive, right? Tangent is positive. Now that's how we can get this one. Just take the square root, right? Just take the square root of this one, and you got that without the negative because it's positive, right? Because it's positive, so we have this. Tangent equals 15/8. Now, therefore, what? Sine of t equals tangent times cosine. Yes? Does that make sense? Tangent times cosine, sine over cosine, right? Cosine cancels out, is sine, so tangent times cosine, all right? So, which is this one is this, and 15/7, right? Sine is fine, so cosecant 1/sine, cotangent 1/tangent. Yes? Now you see the key step here, all right? Most important, most deciding step is to make sure that you identify the quadrant first, right? So we identified this is not given but implied by the value and this range, right? So we can see that it's in quadrant 1. So this is a key step. Another one, of course, is using the Pythagorean theorem identity. Okay, so now here we use the other form, right? Now, of course, you can definitely use, if you after we find a cosine, then you can use the original Pythagorean identity as well, right? To find sine. After you find sine, then everything will be good. You can also do that, right? But you see, we just introduced the other alternative ones, right? So you may just use this, right? This is another way to solve. All right, so now let's move on to calculator tips. Now, okay, the calculator have degree mode and reading mode. Set it to reading mode, right? And choose the desired function and input the angle, right? So of course, if you have degrees, you can always change it back to degrees, right? Change it to degrees. Everything we introduced before, right? You may check the previous notes for the calculation. Now let's see, use the calculator to find these values. All right, use the calculator, okay? So now 1, cosine 23 degree. Anybody remember how to do that in degrees?
Cosine and the second function degree, angle, set degrees.
Yes. Mm.
To 0.9205.
Okay, Nick, can you write it clearly? I do not have my calculator beside me. Sorry about
yeah.
that. So can
That's
you repeat that? So it's a
yeah.
cosine
23 degrees equals
23, 23, and then how to input degrees?
For mine on my TI 84, it's second, and then it's angle, and it brings up the
Second
angle.
and angle, right? Is that right?
And then yes.
And then close the parentheses.
Yep.
And then enter. Okay.
And that gave me 0.9205.
0.9205. Okay. Okay. Did everybody else have any questions about this? Are you good? Good. Okay.
The angle.
Yeah.
Cosine 23 for me. I just like cosine 23 and then close parentheses. Do I have to click angle?
You have to put angle here, right? You have to put angle.
I don't get angle whenever I put second. Or is
the second angle is not on the. You can be careful finding where is the angle located, Nick. Nick, can you tell?
Under mine, it is in the second column, third button down. It says A. It's under apps. It's the secondary function of apps. APPS.
okay. Second angle.
Yeah, and you choose
okay,
degree. You choose degree, right? You choose the degree, right? Select a degree.
Oh, like that. For me, can I just change the modes? Would that be the same thing?
You can change the mode.
Degrees and radians.
But it's better to use radians as the main one. Okay, as the main one. Because in degrees, it's lessly used. All right, because in radians is more common. All right, let's just be you may do that. All right, if you has degree in radian, set it to radian. All right, if you have both degree and radian, set to radian. But if you need, in case you need degrees, you can always use the method here, right? Cosine 23 second angle and choose the angle there, right? From there. Does that make sense?
Yeah.
Okay. Very good. Okay, so for the second, cotangent, negative 2.3. Okay, so for this one, as we said, all right, Mustafa asked this question before the class starts, right? So this one, how to find this one? It's cotangent. We do not have a function given in the calculator, right? So what do we do? It is 1 over, right? Tangent, negative 2.3, right? So this one equals what? 1 over tangent, and you can just use a calculator. 1 over tangent.
I got 0.8935.
0.8935. Yes.
Yeah.
Okay. We got this one. Good. Okay, very good. All right. Now, one thing you have to be, you may be careful is the negative sign, right? It's a negative. It's not a minus sign. Okay, be careful. If you choose a minus sign, you got some error. Okay, you choose the negative sign there. All right, negative and minus sign are different in T83 and 84. Okay. Good. Now, second. How about second? 2 squared minus 1.4. This one equals what? Do we have a function called secant on the calculator? No, we do not. But we know that it is 1 over cosine or sine?
Cosine.
Cosine. 2 squared minus 1.4. This is all in radians, right? This is all in radians. You do not have to change to angle degree. Okay, so okay, so can we use the calculator to find this one?
I got negative 1.1670.
Negative 1.16 what?
70.
70. Okay, very good. Okay, and others. Yeah, please go ahead and find the remaining ones, right? Mm. Mm. Anybody guess on pyrite?
For sine, it was 0.3827 is what I got.
827, and cosine here is
0.9900.
0. Okay, and the last one is
Negative 3.4734.
0.3.4.
4734.
4. Okay, so this one is 1 over sine, right? Very good. Okay. So you can use the calculator to find all this, right? So that's very good. Do we have any problems with this? Are we good with it? Any questions?
For the cosine pi minus 3, I keep getting 0.9899. I just want to know what did y'all do wrong?
Okay.
What would I do wrong?
Yeah, so it's about rounding. It's about rounding to the 4th decimal place. So it's 0.9899. So what's the next value? Next digit? 9. Right? So this
Okay.
is, if you go 1, right, to this, it's a 1, 1, and go here. So it's 0.9900. Did you got this?
Okay.
Yeah, so it's about rounding. All right. You will round 1, and here's 9. 9 plus 1 is 10. You go 1 more to the front. It's again 9, right? 9 plus 1 is 0. So here's 0.990. Very good. All right, I think we finished the chapter 1. Can you believe that? Oh my goodness. All right, so congrats. we got a new chapter today. It's gonna be chapter 2, right? So that's good. All right, we have chapter 2 ready here. Two. Okay, all right, here we go. Now, all right, so in chapter 2, periodic functions. Now, in this chapter, we're mainly going to talk about the periodicity of all these trigonometric functions, right, and including their graphs. Okay, so they have very interesting graphs or figures. Okay, so section 2.1 is about sine and cosine. Now, what do we mean in this section? We are going to introduce what's the definition, right, about period of function, graphs of sine, cosine, and use phase and vertical shapes of sine, cosine curves. Okay, so what do we mean by a period of a function? Okay, the period P of a repeating function f is the number representing the interval such that fx plus p is fx for any value of x. Okay, so equals fx. Okay, so this is the x plus p equals fx, right? So it's always repeating. Now every p is repeats itself, right? So fx plus p equals fx, right? So now these trigonometric functions are typical periodic functions, right? They are very typical periodic functions. Okay, the period of cosine, sine, secant, cosecant is 2 pi. Okay, is 2 pi. The period of tangent and cotangent is pi. Okay, the period of tangent and cosine, cotangent is pi. Okay, here I'm going to just draw a graph for say cosine. All right, I'm just going to illustrate with cosine here. All right, so an important remember in the unit circle, what is cosine of t? Say this is t. So cosine of t equals what? X coordinate, right? Is x coordinate. Is that right? Okay. So if this is t, right? Then if I add a full rotation to the 2t, right? I'm walking on the circumference of this unit circle. Now after t, I take another full rotation, right? A full rotation. After one full rotation, what is my x coordinate?
It would be the same as it was prior to.
Yeah, I returned to the same original location, right? So in other words, cosine t plus cosine 2 pi equals cosine of t, right? Because I got it right back to the original location after a full rotation, right? So cosine t plus 2 pi equals cosine t. Yes, I got back to the initial location. So is again x, right? So you can see if I continue for another full rotation, right? No matter how many here you do, then you just got back 2 pi times 2, right? Equals cosine t equals x, and right? And if you keep making these rotations, you got back to the same location. Yes. A similar thing is for sine, cosine, right? So the sine of t equals y, then sine t plus 2 pi equals sine of t equals y. All right, so and so on, right? So sine t is the same thing, right? Okay. So that's why we are saying the period of cosine and sine are 2 pi, right? Are 2 pi. And secant, since secant and cosecant is the reciprocal of cosine and sine, so they have the same period. Okay, they have the same period. Now, the period for tangent and the cotangent, right, is pi instead. It's not 2 pi, right? It is pi instead. All right. So that you have to be careful because they are all the functions. All right. So tangent goes here, right? So negative equals negative, so it's going to be pi instead. Okay. All right, so I'm going to do the, all right, based on these ones. All right, so let's consider the following example. If secant t equals -2, can you find secant 4 pi plus 2? 4 pi plus t? Is that right? Yeah, because it has a period of 2 pi, right? So after you just make 2 full rotations, you got back to the same point. Secant, you see, secant has the period 2 pi, right? So we have that. This is going to be A. How about B?
B would be, since it's the same, it would be, because it's a -2 pi, it would still be, if you go in the opposite direction, it would still be the same because it's still going back to the same spot.
Exactly, right? Cosine function has a period of 2 pi cosine t minus 2 pi equals cosine of t equals 1/2. Because if you go opposite clockwise for a full rotation, you return back to the same position as well. C. Okay. What about this one? Okay. So for this one, it's a little tricky. All right, you have to be careful. Hint: find the cotangent negative t first. Right. So cotangent is an even function or odd function.
Odd function.
It's an odd function. All right, cotangent is an odd function because it is sine over cosine, and we know that it's sine is odd, cosine is even, right? So Good. All right, so this is to use the periodicity function, periodicity of these trigonometric functions, right? So we can find the values of the related of the function, the values of the functions at some related points. All right, so just be careful about this periodicity, right? So they repeat after certain time, right? Certain period. Okay. History repeats, right?
Yes, yes.
Okay. All right. So let's consider graphing sine and cosine function. Okay. How to graph sine and cosine function, cosine and sine functions, right? How to graph them. Now the graph of this function is basically what we do is we just select certain points on, say, the sine of x, right? So you have x value, you have sine of x, right? We can just select this certain certain value for x and find the value for sine of x, and then we can just using a smooth line to connect them, right? To connect them. So between 0 to pi, we have 0, 6 power 6. These are the special values of special angles, right? Special angles. So 0 sine of 0 is 0. Sine power 6 is 1/2. Sine power 4 square root over 2. Sine power 3 is this. Sine power 2 is 1. Sine, and these ones, right? So we know how to find all these. These are special angles, right? So from chapter 1, if you remember, all right, so we have what? The unit circle, right? So, okay, so let me just go back to this one, right? This guy. If you remember this figure, right? So this figure is so important. It gives us all the coordinates and they're at those special angles, right? X is the cosine, y is the sine, right? So from this, we can have all the values of cosine and sine at all these special angles. So from that, we can get all these ones. Sine is going to be the y coordinates, right? Sine is going to be the y coordinates. So we can just like what we did, right? 0, 0, so it's at the origin, it wants to go through the origin, right? Pi over 6, 1/2. So it is this point, and then pi over 4, square root of 2 over 2 goes here, square root of 3 over 2, and pi over 1, down, right? And then you can do something more, right? And you got these points. When it is 2 pi, sine 2 pi equals what? Well, sine 2 pi equals the sine of 2 pi plus 0, yes? By periodicity, 2 pi is the period, correct? So it equals sine of 0. Yes? So equals 0, right? So that's why here it's 0. And then we can just use a smooth curve to connect all these points, like what they did here, right? Now it looks like this. All right. Now, of course, you can add more points. If you use a calculator, you can add more points such that your graph get more accurate. Yes? Or your points got more accurate. All right, so this is, of course, is between what? 0 and 2 pi. The curve looks like this. All right, it runs through the origin, from the origin, right? And it goes up. At pi, it is 0, right? And then, and got here, right? Stopped at here. So this is the plot of the sine function over the period 0 2 pi. Yes. Now, what about how is going to do after 2 pi?
It will match the way it was at the beginning of the chart, where we'll continue back up.
Yes.
Make the arc again.
Yeah. So because what?
It's periodic.
It is periodic, right? It repeats for every 2 pi, right? So this portion, this section of the curve will repeat, right? This is from 0 to pi, and from 2 pi to 4 pi is going to be a copy of this, right? And then another copy of this, and so on, correct? So it goes all the way to the end of time, right? Till the end of time. Okay. Can we help you? Just 1 second, please. Okay. So, all right. Okay. Okay, we were just checking. Okay. Yeah. Okay. Oh, no worries. Thank you. Oh, okay. All right. Let's do this one together now. Okay, so um, from 0 to 2 pi, and we have this one. So this one will repeat till the end of time. All right. And what about the other side? Go to the negative infinity. That's again, right?
Right.
Repeat from negative 2 pi to 0, negative 4 pi to negative 2 pi, and it goes to backwards, right? So it's going to repeat as well. Now, in other words, you can just get a what? Get a period. If it is a periodic function, you can just get a curve for one period, and then everything else will be good. Yes? Okay, very good. Okay. All right. Now let's consider the cosine, right? So for cosine is also very interesting. All right. So at 0, well, it's just from that what? From this one, right? So you can pick those special angles and put there. You got this table at 0.0 cosine, and 0 is 1. And you got all this, right? So 0, it is 1, and this, and here, 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 right? Does that make sense? Okay, so, and also you can get all the others actually, right? So 0, and 1. Yes. Okay, so basically you got all these points, and then you connect them, right? We use the smooth curve. All right, this is from 0 to 2 pi. This is how it looks like for cosine, right? And then this will repeat, repeat, and repeat. Yes. So basically that's how we do. All right. Okay. So we have that. What about others? What about the others? Okay, so that's what we do. Okay, so these two pi will repeat, right? So we'll repeat again and to the infinity to negative infinity, right? It will repeat. So that's basically what it means. Okay, all right. So that's the plot of cosine function. Yes. Okay. Okay, so we you see this is what we mean, right? So we say they repeat, and this is how it looks like if we make them repeat, right? So sine and continue, right? So you just do this and that. Okay, well, you cross the border. No, that's not good, right? So and you go back, right? So and so on. So this is how it looks like. Um, you see, negative. This is going to be one period. You see that this period repeats, right? So this period repeats. Okay. Okay. This is the sine function is odd because you see if you do two periods from 0, negative 2 pi to 0, 0 to 2 pi, and you see that it's reciprocal, it's symmetric about the origin, right? It's symmetric about the origin. Yes? Okay. Symmetric about the origin. So we know that it is odd. Okay, so this is, we have what, two periods of the function, right? Two periods of the function. And similarly, cosine is symmetric about the y-axis, as you can see, right? So now this point, this point, and this point, and this point, right? They are symmetric about the y-axis. Yes? They're symmetric about the, it's mirror, it's like a mirror, right? So about the y-axis. Good. All right, so here are the summary of the characteristics of sine and cosine. All right, the sine and cosine functions have several distinct characteristics. They are both periodic with a period of 2 pi. Yes? The domain is always, well, negative infinity to positive infinity, and the range is negative 1 to 1. Yes? Okay, we learned this. The graph is symmetric about the origin, it's an odd function. Symmetric about the y-axis, it's a even function. Yes? Okay. Now we should be able to, you need to memorize. All right. This, you need to totally understand and memorize the graphs of sine and cosine. Okay, these two. All right, this is extremely important. All right, so because um, sometimes well, well, one thing is you to memorize this when you use the sine is symmetric about the origin. It goes through the origin. It starts from 0 and it goes up and goes down and then it repeats, right? So this is the sine. But for cosine, it starts from 0, 1, right? It starts from 1 and drop, increase and drop and increase and so on, right? So that's the distinction between sine and cosine. All right, so you can, you definitely need to memorize sine, cosine, the graphs. Okay, so what kind of properties they have, and so on. Now, in general, here is something in general. So in this one, we just find the sine of x. You see, this is cosine of x, sine of x, right? Now, we are going to talk about the sinusoidal functions. What do we mean by sinusoidal functions? Or functions of the form, right? Y equals a sine bx minus c plus d. Y equals a cosine bx plus d. Okay. Now, for instance, all right, for instance, one general form can be what? Y equals 2 sine, all right, negative 2bx minus 3, let's say that, and say plus 1. Function something like this one, right? Something like this. This is an example, right? So A, B, C, D are constants here, where A, B, C, and D are constants. Now here you have to be careful with what? We only have B, right, as non-zero. Okay, B is non-zero. Okay. All right, B cannot be 0. If B is 0, then it's just a constant, right? It doesn't change with back to x, right? If B is 0, then what's the point, right? Does that make sense? Okay. All right. So the periodic, the period of sinusoidal functions. All right. The period of sinusoidal functions is 2 pi over the absolute value of b. Okay. P equals 2 pi over the absolute value of b. Okay. Now, for instance, I have these ones, right? So in this graph, you can see, as you can see, this is sine, right? And in the black, oh gosh, I messed it up. Okay, so the what is the blue curve, right? The blue curve is the sine of x, and the red curve is sine of 2x, right? Sine of 2x. Now for this function, the period is going to be what? 2 pi over 2 is pi. And this is exactly true, right? So from 0 to pi, pi to 2 pi, you see the red curve, right? The red curve repeats every pi after every pi, right? So pi, the period is pi. For the green curve, all right, so sine x over 2, p equals 2 pi over the absolute value of the coefficient, 1 over 2, and this is 4 pi. Yes? Okay, so therefore we have this is 4 pi. Okay? And then the fx equals for this sine negative x, right? Sine negative x is the same. All right, so sine negative x equals 2 pi over the absolute value negative 1, so which is 2 pi, and sine this one, so b is going to be what for this one? B equals negative 3 over 2, right? Negative 3 over 2. So it's 2 pi over that. That's going to be this. Make sense? Anyway, that is the point. All right, the period of the sinusoidal functions, p equals 2 pi over absolute value of b. Yes? Okay. Good? Okay. All right. Okay. Mashafa, can you read for us, please?
Determine the period of the function fx equals sine 3x plus 6 over 5, and then B is determine the period of the function f of x equals cosine negative 2x minus 1 over 4.
Yes. All right. Go ahead and see if you can find this. Right. So we want to determine the period. Now, in order to determine the period, you need to find the value for b, right? And what are b's in these functions? Okay, good. All right. So for a, fx equals this one equals 1. If you divide it by 5, so the common, this is sine 3x over 5. Sine 3x over 5 can be written as 1 over 5 times sine, right? So which is going to be that, and plus 6 over 5, yes? So which means what? B equals 3. Good. B equals 3. So therefore the period is 3 pi over 3, 2 pi over absolute value of 3. That's 2 pi over 3. Now, similarly for the second equals, we can rewrite it in the, we want to got the notation in this form, right? So the general form, A sine plus D, right? So now for this one, D is all, this C term is all 0, right? There's no C term here, right? X, there's no C term. So we have C equal to 0 and everything is given here, okay? So we're determining the period, so it doesn't matter much about the C and other values, but we only need to identify the value for B, right? So, okay, so again here, we introduce the second concept related to sinusoidal functions, which is called amplitudes, right? The amplitudes is of the function is the absolute value of A, right? The amplitudes. Okay, so consider the following functions. It looks so great. I like this curve, right? So, and when you graph mathematical functions, they just looks so gorgeous. Look at that, right? So just look at that. I mean, how can you create such beautiful curves, right? I mean, if you put them together, they just look so precisely and aligned so well. It's just beautiful. I hope we can make some creatures. You know, so some figures is just to be there, and you can automatically feel the beauty, and you love it, right? So give us a satisfaction of these visual feelings, and this is just great. All right. You have this, okay, so just consider these four functions here, right? Fx equals 4 sine, 3 sine, 2 sine, and 1 times sine, right? So their amplitude are different from 1, 2, 3, 4, 4, 3, 2, 1. And then you can see how these amplitudes change the shape of the function, right? So B, everything else all the same, sine x. The only thing is different a's, right? So you see how they look like. Okay. Now, if a is greater than 0, the function is stretched vertically. All right. If a is less than the absolute value is less than 0, it's compressed vertically. Okay, it's compressed vertically. So it's something like this. Okay. All right, let's consider again some examples of this. All right, now I want to say, okay, let's just go with this. All right, consider this example. Okay, Jared, can you read for us, please?
Determine the amplitude of the function if f of x equals negative 3 sine 3x minus 1 plus 6 over 5. Is the function stretched or compressed vertically? B. Determine the amplitude of the function f of x equals negative 3 cosine negative 2x plus 2 minus 1 or negative 1. Is the function stretched or compressed vertically?
Okay, very good. Very good. Okay, sorry, there's no close, no this, right? Okay, solution. For A, can you go ahead and find the amplitudes, please, for A and B? Does that make sense? Okay. So now the key point here is to write the form of the function into the standard form, right? Like this, the sinusoidal form, like these forms, right? You need to convert. If it is not in this form, you got to convert it into such forms. Yes, into such forms, and then the amplitude is just absolute value of a, right? So now for this one, you got to write it in this way so that a is negative 3/5. Yes? Okay. Now, it's not negative 3, right? It's not negative 3. Okay. So be careful. You got to rewrite the form into the standard form, right? And then determine the value for A, B, C, D, and so on. The amplitude for this one is negative 3/5. Okay. All right, and for the second, it's already in the standard form, right? So we can just put the A is negative 3, so good, everything is good. Now let's consider the variations. All right, so the other two, okay, so the sinusoidal functions, okay, and they can be rewritten as what? Rewritten as this. All right, so consider this. B is not 0. All right, here B is not 0. Okay, so this one can be rewritten as B in the parentheses x minus c over b. Yes. Okay. And plus d. Okay, and y equals what? A cosine b x minus c over b plus d. Okay, so now based on this one, we determine the following shifts. Okay, the shifts. Oh gosh, my goodness. Oh, my goodness. I remember when I was learning English, starting learning this, just got to this word, and I have been saying instead of my goodness, I have been saying like my godness, for many years. And every time I say something like my goodness, I say, oh my godness. Godness. And nobody corrected me, and until after my marriage, after I married my wife. My wife has been correcting me for so many things.
That never changes. That never changes.
Oh, well, for this one it does. My goodness. My goodness. Well, if I say my goodness to my wife, she's happy about it.
Yeah.
She's okay. Yeah. So anyway, phase shift. All right, phase shift is C over B. Okay, so C over B is called the phase shift. It is the horizontal displacement of the basic sine and cosine. Right. So now here phase C over B. Right. If C over B is greater than 0, then shift to the what? The displacement to the right. Okay. If C over B is less than 0, to the left. Okay. Now vertical shift is D. All right. Now similarly, if D is greater than 0, it's going to be vertical shift, right? Shift upwards. All right, if D is less than 0, shift downwards. Okay. And the midline is called y equals D. It's called a midline. All right, it's called a midline. All right. Okay, so we have what? The phase shift, right, is defined as C over B. Now, vertical shift is defined as D, right? And if the phase shift is positive, that means the horizontal displacement to the right. If the phase shift is negative, the horizontal displacement to the left. If D is greater than 0, we shift upwards. If D is less than 0, we shift downwards, right? So, and the midline is called y equals D. Now, these are very important, right? So you got to make sure that you identify these coefficients A, B, C, and D correctly, right? Correctly. Here, B will determine the period, right? A is the amplitude, right? Determines the amplitude. C over B is the phase shift. D is the vertical shift, right? So y equals D is the midline. Oh gosh, I wish I had more time. Okay, so I don't think we can finish this one, right? Finish this example. All right, I think we can stop here and we will continue tomorrow.